All right. So welcome back to Physics 112. Today is the second review session, and I want to lecture about interference. Finish the section about interference. Okay. Oh, one thing is that I'll return to you. So I will have to run to a Zoom call right after the class. So if you want to discuss, if you have any logistic question, now is the time to do it. No logistic question? Yeah. Do you still want to ask your question or no? About what? Which one? I went over the study guide this morning. I couldn't find. I did find a few duplicate questions. So I'm sorry for that. But I think all the difficult questions, I did line by line solution for those. And then if you have any question, feel free to email Ross and all the LAs and see me. Yeah. Yeah. It's an A range. A range means A minus, A, and A plus. So the unbiased way right now, because I don't have a complete information. So I did this, so 85, so first 75 to 85 is B range, so B minus, B, and B plus. And the unbiased way to answer your question right now is just divide these three equally. Similarly, I think 0.4, but let's make it 0.5 because this one is actually 85 plus 3 times 7.5. So divide this. So this one is 85 plus 7.5. This cutoff here is 85 plus 2 times 7.5. So this one is roughly, it may change. It is likely to change. But at this point, this is the best thing that I can do. That's unbiased way to assign the threshold between grades. And then similarly, I think we put 65 here. So divide this into 3. Yeah, if you're happy with your grades, yeah, because the semester is still it's still part of spring semester, right? Because otherwise, I cheat you. You shouldn't be happy if somebody cheats on you. Right? Like you pay the same tuition, you should get what you pay. Yeah, because otherwise it's not fair for your friends who will be in the class. I mean, I think education is one of few or the only business where the customers are happy when they are being cheated on. So the same thing with, I know some of you are not the biggest fan of Perusal, but some of you will go to grad school. My neighbor and my lab mate when I was in grad school, he's from Korea. His undergrad was biology. His name is Jongmin Kim. He not only he buys books, not only he reads them because I see all the highlighted sentences. He also did all the exercises. So those are the people, whether you like it or not, those are the people that you will compete against. Especially if your goal is, I don't know, you want to start $1 billion company or you want to thrive in company, those are the people that you have to compete with. So perusal is not only just for physics, but it's to build habit. It's for you. Whether you read or not, my salary stays the same. So it's not for me. So yeah, for those of you who just got here, I will have to run quickly after the class. So if you have any question, now is the time. I'm gonna meet with intelligence company who give me a lot of money, and I think they're not happy with me, so I have to be on the meeting on time. Everyone is unhappy with me. Okay, no more question. Good. So I received an email yesterday from ASU. Only about 15% of you failed the course evaluation. How many of you is not planning to do to fail the course evaluation? Only one. So all of you except Matthew is going to fail the course evaluation, right? Okay, good. Is that right? I'm just reading the room here. So remember, this is the best class on campus. Anything else? You don't have to be here next week, by the way. It's not. I'm not gonna take it personally. When I go to work, when I go to this class, I left my ego in my car. So you don't have to be here, but you will get 0 iClicker question. Yeah. Good question. Again, this is my. I'm really sorry, but he wants like 4 week notice. Like Phoenix children want 4 weeks notice. I can still arrange a Zoom call, and if I would be the only one who come, that's fine, because I need to learn how to better connect with pre-meds next spring if I don't get fired by ASU. Yeah, but he maybe in 4 to 6 weeks. Yeah, and because that's one thing that I need to improve on, right? I understand that pre-meds, all of you, well, all pre-meds in the room is under a lot of pressure. I need to be more sensitive with that. Any questions from this side? Because typically I lecture to this side somehow. Ella, Megan, Eva, and your friend, no? Okay. Maybe continuing these logistic themes, I posted the mind map for exam 4. So you can follow this. If I miss any topic, you should let me know. Basically, there are a lot of lines because the most important principle in optics is Fermat's principle of phase-time. And there will be question. And we can even do demo. Well, let's do app first. So I found this, sorry, why it didn't work? Oh, here. So I found this app, Korean app. Maybe Korean app is the theme of the day. So this is a demo, so I can reset, and you can control the speed. Okay, first, what is this? There is this person that runs and swims, and right now he can run twice as fast as he swims. Okay, but let's make it the same speed. So if it's the same speed, and let's say this person, he or she, has options between different paths. If we run this simulation, then the path that takes the least amount of time is the straight path. But because most of us can swim, and most of us swim faster or slower than we run, then if we run the same simulation with the running speed is equal to twice the swimming speed, then the path that takes the least amount of time is not the straight path. So this path here, okay. So that's one. And we can also do real demos, meaning like show you with lights. So didn't set it up before. Any question about Fermat's principle of least time? There will be question about Fermat principle of least time. Okay, so doesn't work. Maybe I can just hold it. So there is this. So what is this? This is what we call collimated beam. So it's basically parallel lights. Okay. And then this one is just, I assume, plexiglass, but you can consider that as glass. But I think this is plastic. So if, let's say, so at this point, light comes at zero incident angle. And because zero incident angle, then zero, the refracted angle is also zero, meaning light doesn't bend. But I can change the angle of the glass. Well, this one is easier. And what you see is that light bends. Like this light bends. This because this one follows principle of least time. Okay. So on the exam, I may ask you different types of principle of least time. Yeah, how many things that have. So for example, I can say like, oh, somebody has, like this person wants to meet another person here, person A and person B, and there is a channel or a swimming pool. What is the path that takes the least amount of time? So the answer is, so this is swimming pool. This is, I don't know, yard or something, or garden. And then I will ask you to pick the path with the least, that takes the least amount of time. Of course, the answer is not this, right? As we have done before, as you have seen before. This is basically the swimming pool right now. Okay. The answer would be, you want to take a little bit longer path here than this. And then. Okay. So if there is any question like this on the exam, I'm giving you 1 free point, by the way. This is the answer. B, not A. Okay. And then there will be different variations, you know, swimming pool. The swimming pool has a shape of like teardrop or like eyes, not eye, lens. It's another way of testing you whether you understand the principle of this time. Okay. All right. So some people like this mind map, and you're welcome to use it. So when I was your age, sorry, I should stop saying that. When I admittedly did this when I was an undergrad. Instead of understanding the material, I prepare, because every subject, there are only probably 10 ways that a professor can ask or can produce good questions. So I try to come up with those questions and answer them. So before the exam, I know exactly, not exactly, I have a good guess of the questions without understanding the material. Don't do that, but this is my way of hacking the system. Well, this is being recorded. So let's return to the script. Yeah, so there is this mind map. I don't remember. I think Michelle asked me about this yesterday. Yeah. Yeah, good. So the path. So what is principle of least time? So Estefana asked a good question. It's basically if you have 2 points, starting points and finish point, light doesn't have to follow this path, right? It could go this path if it wants to. But in nature, light follows this path here. And you can actually compute the path using law of refraction, but also you can derive Snell's law using principle of least time, because this path here, path B, is the path that takes the least amount of time from point A, from point A, not path A, to point B. If you're curious, you can have this distance, and then there is a speed on yard. The distance here is maybe R2, and then the speed is, I don't know, V swimming pool. If you do a little bit math, you will arrive at Snell's law. Okay. And let's finish the discussion of Fermat's principle of least time. Okay. So this is a converging lens, and it's not perfect because the light is not perfectly collimated, and there is also chromatic aberration, which we didn't discuss in the class. So for here, basically there are different starting points, but the person who designed the shape of this lens used Fermat principle such that different points from a collimated beam arrive at single point with the same at the same time, which is the time that is the time such that all this path takes the least amount of time from these points to the focal point. I don't know whether that thing is clear. Basically, the difference between this analogy and lens is that there are different points here. But since the swimming pool is not, the shape is not lens, then there is no focusing effect. Okay. But I think in one of the slides, we did a swimming pool with lens shape. And if we start here and finish here, we can arrive at this point with the same amount of time. That takes the same amount of time whether we use this path, or this path here. Because the middle path takes longer, meaning like spends more time in the swimming pool, but the total path is shorter than if we touch the edge of the lens and go to the other point. So maybe we should do interference. So for exam 4, typically students do the best. And the way to do that is by practice. So if my friend asks me to play basketball with him, I will do horribly because I don't exercise. Right? But my friends, which is a former professional athlete, always tease me to play basketball with him. He can shoot really well because he practiced. Similarly here, if you practice using let's say our this table, then during the exam you can just use it. So the key is practice. Don't use your exam as your practice time. Okay. All right. So should we discuss interference? So interference is very important in quantum mechanics and also in physics. So interference. And by interference here, this is different than interference in biology. Like there is nothing to do with, I don't know, small interfering RNA or RNAi, siRNA. But it's basically the interaction between two waves. So first, I have a simulation here. I wrote this morning. I'm going to restart. So we have two waves here. The blue wave, I call that wave 1, and the red wave. And they are monochromatic. Monochromatic means it has one wavelength, and coherent. Coherent is they have the same phase. When one wave, at one point, if one wave is at its valley, the red wave is also at its valley. But it doesn't have to be like that. I can shift one of the wave, and because this wave is a solution of wave equation, the other wave is a solution of wave equation. One thing that we skip in this class, it turns out that this wave equation is linear, meaning if you multiply one solution, it is still a solution of wave equation. If you sum two waves, it also still satisfies wave equation. Okay. So I'm not going to ask you this question on the exam, but if somebody say that the solution of wave equation or wave 1 has to be positive, what is your answer? Meaning how to argue against that statement. Am I speaking English? Sorry, it's a mathematical question. So the answer is no, because if you multiply a constant wave solution like this sinusoidal wave, it still satisfies the requirement for a wave. That means you can multiply by, let's say, -1, and it's still a solution. Okay. So anyway, you can sum. So the top is wave 1, the second one, the red wave, is wave 2. The last one is the sum of wave 1 and wave 2. When they're coherent, they have the same phase. Then this point plus this point here is the sum. So 1 plus 1 is +1, 0 plus 0 is 0, right? So if they are in phase, the sum, we call that constructive interference. But we can shift one of them by 180 degree, basically. 180 degrees. Okay. So when one wave at its maximum, the other wave is at its minimum. So you sum 1 plus -1 is 0, 0 plus 0 is also 0, and you get basically destructive interference. And yeah, so this is in the class we discuss about AirPods. This is how AirPods work. Basically, the blue wave is the noise from the environment, but AirPods read and predict the future wave and generate the same wave, but shifted by 180 degrees. And then because you hear blue wave that your surrounding generates and the red wave that your AirPods generate, your brain sum the two waves and you get noise cancellation. All right, so so these two are one of the like two of the requirements of interference. There is another one that we discussed last time. What is the Sarah? Where is Sarah? Sorry, not you. The other two Sarah. I forgot to check before the exam. How about Milan? Yes. Yeah. What is the other requirement? It starts with X. So the size of the aperture, the size of the opening or the optical device is comparable to the wavelength lambda. And this is why if you run interference experiment in your apartment or your house, you open two windows, you don't see interference because your house is much bigger than 500 nanometer. Okay. It doesn't mean that the interference is not there. It's just your eyes cannot see fringes at nanometer scale. I just need to cover 2 more slides. So I don't think I can demo it now, but some of you use this software and some of you had difficulty in switching between different pages. You can get the, I guess, table view and click outlines, and you should be able to switch between different lectures. Okay. Anyway, so but this is not the right file. Let's use my computer then. Oh, sorry. And similarly, on your computer, you can open the table of contents and you can jump between lectures, or you can click all these buttons here. Okay. Sorry if I didn't make that thing clear. So interference. I want to cover this this slide here. So basically, interference, we have 2 openings, slit 1, slit 2, or source 1, source 2. The symbol that textbook uses is S1 and S2. Okay. And the source has to be monochromatic and has to be coherent. The way people do it is they have one opening here, and you have a light source here. I don't know, source, super source or something. Then the light will travel through this opening, another opening, and then you have a screen here. And the distance between the opening and the screen is capital R. So Thomas Young did this experiment, and he basically proved that light is a wave, okay, which is consistent with what Maxwell and Faraday conjecture at that point. So how did he prove that? It turns out that if the size here, so the distance between this point and this point is d, you can call that distance. And then if the brightness, I plot the brightness here, the further from the screen, the brighter the image. So it looks basically like this. The pattern will look like this. So it looks, Thomas Young saw fringes. Okay. Which using geometric optics, you wouldn't predict that. I think the way I describe it on Friday is that if X is much larger than, if the size of your apartment or your house is much larger than 500 nanometer, when you open 2 windows, the room will get brighter, right? But here, some areas of the room or the screen actually gets into complete dark or complete darkness. So so the way people describe this phenomena is using interference, which is, I think it's pretty cool, because when you think of football, interference involves 2 things, right? But in physics, you can have an interference using only one source. I thought that's a lot of fun. All right, so let's use this point here. And I'm gonna use 2 colors. S1 is blue. So at this point, the path that S1 takes is, I call this R1. And the bottom source, or the bottom opening, or the bottom slit, takes a different, you guys need to help me with this, different path, which is R2, okay? And R2 here is longer than R1. So when they arrive, when the wave that passed the first slit arrive at this position, it will arrive at different phase than then the wave that pass through the source too, or slit too. You get it? Okay. And I think this is this. Oh, I need to add one more slide. It's basically in the here. Okay. So the path diff. Oh, yeah. Confused. So the path, the distance difference, R1 minus R2, if it's equal to integer, and the integer doesn't have to be positive or negative, it can be 0, then we get constructive interference. So similar to what I show here, right? So 0 phase difference, we get constructive interference. But if the difference of the paths is odd number times 1/2 of wavelength, we get destructive interference. So for that thing, the phase difference is -80. Okay? But if you, on the exam, sorry, if you use this formula, you should be good. And M can be 0, plus minus 1, and plus minus 2 to basically infinity. Any question? So why we have those numbers? Because we have so many fringes. So the fringe that is in the middle here is 0, m is equal to 0. The next one is m equal to 1, and m is equal to -1. The dark fringes, the destructive interference is m plus 1/2. And m, if m is equal to 0, then this number here is equal to 1/2. Any question? Yeah, Gabe. M. Yeah, good. M here is integer, but this is the pattern that Thomas Young saw. Okay, the center one is m is equal to 0. So if m is equal to 0, then for the first constructive interference, like the bright fringe, here is m lambda. So R2 minus R1, then it's 0. And then the next one is m lambda. Oh, how to say this? The path difference is equal to lambda, because you put +1 and -1. So maybe here also. Basically, if the path is shifted by lambda, then you get constructive interference. If the path is shifted by m plus 1/2, then you get destructive interference. Here, if m is equal to 0, then you get lambda divided by 2. If m is equal to m is equal to plus minus 1, then you get 3/2 times lambda. Okay. Yeah, Malika. The index, yeah, the index. So you have many fringes, and the index of these fringes, the center one, the middle one here, the middle one here is m equal to 0. This is m equal to -1, m is equal to +1. Okay. So there is a question in, and let's do a clicker here. Okay, there is a question on your study guide. let's say you have two sources, and the path difference, I think one of them is 4.3 lambda, the other one is 7.3 lambda. The question is, at this point, so you can call this R1 or R, and this the other one R2, or the opposite. At this point here, this is screened. Do you get constructive interference or destructive interference, or none of the above? So I'm gonna push this to I clicker. Okay. Good. 10 more seconds. So let's spend 30 minutes, 30 seconds, sorry. Three more seconds. 2, 1. Okay, good. I think most of you got it right. Either you study or you already understand the material code. I hope both. Okay? Not either, and or. So what is the difference of the path length? 7.3 minus 4.3 is 3. And this satisfies the first one. Okay. Which is, if m is equal to 3, then it satisfies the condition, then we get constructive interference. And then I think this is what the the same problem or similar problem. No. Similar problem on study guides. So let's say instead of 4.3, you get 4.8. So at the same point now, so to do that, you know how to get this 4.8, right? You just move this point closer. And then this path will get a little bit longer. So the question is, at the same point, is the wave, do you see destructive, constructive, or neither destructive nor constructive interference? Ooh, doesn't work. All right, so I'm good. So 5 more seconds. 3, 2, 1. Okay, good. So the answer is B. This is because 7.3 minus 4.8 is 2.5. If you put m is equal to 2, then it satisfies the condition for the destructive interference. Yeah. Yeah, for this class, none of the above. There is a different answer for a different class. But for this class, it will be none of the above. So let's say instead of 4.8 is 4.81. In this class, it will be none of the above. Okay. Mark, any question? Yeah, you. Mark. No, good. Okay. So And then after this, it turns out that the path difference, remember we have two openings. It turns out that the path difference is equal to, if it's D, and this angle here is, there is this angle here, which is theta. Okay, so let's make it more clear. If we take the length of the shortest path and then subtract that from the longer path, when I say shorter, I shouldn't say, I should say shorter, not shortest, but it's also shortest because there are only two paths. Then the difference of the path, so R2 minus R1 is this one, okay? It turns out that R2 minus R1 is equal to D sine theta. So I'm gonna add a slide on that. And then during exam, I will give you the equation. This one is equal to D sine theta. And then you can do approximation. So the approximation for sine theta, as long as you promise that theta is small, this is equal to y divided by r. Again, r is the distance between the two openings and the screen. And y is the distance between this axis here. We can even call it, I don't know, normal or principal axis, and the position here. So this is y. And y depends on m for constructive and destructive. Okay? Because R2 minus R1 is either equal to m times lambda for constructive. I don't have to write the whole thing, right? Or m, the odd number times half lambda for destructive. Okay. So this is the end of the material for exam 4, not for the class. Basically, the path difference is, as long as you promise that theta is small, then it's equal to approximately equal to vertical distance, where this is the position of the fringes, and the distance between the openings and the slits. So on the exam, I may ask you what are the requirements for interference. So the source has to be chromatic. You cannot use the light from the sun. The source has to be coherent, meaning the two openings must have the same wavelength and phase. And also the size or the distance between the two openings is comparable with the wavelength of light. And I expect you to be able to do this. And all the equations will be added to the equation sheet. Are you guys okay? So this is the end of the material for exam 4. Ross will, what is that? Ross is planning to have a review session. I don't know when. You should ask him. How about the recitation? You guys get 100% or how? Sorry. How did you get the score? You don't know? Huh? Did you do quiz or no? No, I see. Interesting. Okay. Then this class is, you should get good grades from this class, right? You get recitation point for free. Okay. You should thank him. Any other question? Last question. This is, oh, wait. Sorry, this is an important question. What is your question again? Sorry. Oh, for the final, no new study guide. Uh, it's cumulative. So it's going to be, don't study the night before. Right? Don't send me an email the night before, like, how should I prepare? But the exam is designed to evaluate your understanding throughout the semester. Okay. Good luck with exam 4, and I'll see you on Wednesday. Yeah, I have to leave.